Okay, so in this video I'm going to take a look at the mock paper, Leave Cert Higher Level Maths from 2019. This is the DB paper. So it's going to be quite a long video. The exam, as you can see, is 2.5 hours long. So I imagine the video will probably take me a similar amount of time because I'll be explaining each part as we go. So let's get started here with question 1. Question 1 is a complex numbers question, and the first part says 2 minus I is a root of z cubed minus kz squared plus 21z minus 20 equal to 0, where k is an element of the real numbers and I squared is equal to minus 1. Find the value of k. So because 2 minus I is a root of the equation, I know that if I sub in 2 minus I, then the equation will be balanced. So the f of z will be equal to 0. So I'm going to sub in, instead of z, I'm going to sub in 2 minus I. So the f of 2 minus I is equal to, that'll be 2 minus I cubed minus k times 2 minus I squared plus 21 times 2 minus I minus 20 equal to 0. So let's cube out this, square out this, and just see what happens. The only unknown in here is k, so that means I can solve for k. So I just need to work through it with my algebra to get down to the final answer. So to cube out this, what I'll do is I'll say 2 minus I times this squared. So to square it, it'll be the square of the first, which is 4, twice the product, which is minus 4i, and then the square of the last, which is plus I squared. Minus k times, squaring this out again, I get the same thing, 4 minus 4i plus I squared. And then 21 times that there would be plus 42 minus 21i minus 20 is equal to 0. Okay, so if I work through all this, multiply out this and simplify it down as far as I can, I eventually get down to 24 minus 3k plus I times 4k minus 32, and that's equal to 0. So I've worked through this, through my algebra. I've isolated the real part and the imaginary part. So if this is equal to 0, then that means that the real part is equal to 0 and the imaginary part is equal to 0. So I can say 24 minus 3k is equal to 0. So minus 3k is equal to minus 24. So that means k is equal to 8. And then over here, I have 4k minus 32 is equal to 0. 4k is equal to 32. So again, k is equal to 8. So it makes sense that we get one answer for k because it says find the value of k singular. Part 2, find the other two roots of the equation. Well, the first root is easy. So if I have if 2 minus I is a root, then the conjugate of it is also a root. Then 2 plus I is also a root. So you should know that complex roots always come in conjugate pairs. So 2 minus I, the conjugate of that is you just change the sign in front of the I. So that's, the conjugate is 2 minus I. So we already have two roots now. So we just need to find the third root. Right, so if we have two roots, how do we find the third root? Well, we start off by saying z squared minus the sum of the roots plus times z plus the product of the roots is a factor. So if we have two roots, then together they can make a factor of our thing we're looking for, f of z, which we're given at the start. So if we find the other factor, then we can find, if we find the factor that the two of these together make, then we can find the third factor, and if we find the third factor, then we can find the third root. So this polynomial here will be z squared minus the sum of the roots, so that's 2 minus I plus 2 plus I times z, and then plus the product of the roots, which is 2 minus I times 2 plus I. So that's z squared minus 2 plus 2 is 4, minus I plus I is 0, so that's minus 4z. And then the product of the roots over here, 2 by 2 is 4, 2 by I is 2i, minus I by 2 is minus 2i, so that cancels out. And then I minus I by plus I is minus I squared. Remember, I squared is minus 1, so minus 1 times a minus will be plus 1, so that'll give me 4 plus 1 is 5. So that means z squared minus 4z plus 5, when that divides into our original equation, the answer we get will be the other factor. And we can use that other factor to find the final root. So we're going to go and do a bit of long division here. So it's z squared minus 4z plus 5. And we're going to divide into the original thing that we had. So z cubed. Now instead of minus k, it's minus 8z squared, because remember we found that k is 8. Plus 21z minus 20. So do our long division in here. So z into z cubed goes, or z squared into z cubed goes in z times. Multiply down, z by z squared is z cubed. Z by minus 4z is minus 4z squared. And z by plus 5 is plus 5z. Change the signs, so they'll cancel. Minus 8 plus 4 is minus 4z squared. 21 minus 5 is 16z. And then we bring down our minus 20. Then we divide in again, so z squared into minus 4z squared goes in minus 4 times. Multiply down, minus 4 by that is minus 4z squared. Minus 4 by minus 4z is plus 16z. And then minus 4 by plus 5 is minus 20. And then once these all match up, we change the sign, they'll all just cancel out. We get 0 down here. So that means that this is our other factor. So therefore, z minus 4 is a factor. But we weren't asked for the factor, we were asked for the root. So if z minus 4 is a factor, that means z equal to plus 4 is a root. Therefore, z equal to plus 4 is a root. So the other two roots were 2 plus I and 4. Okay, so on to part B then. Find the square root of minus 1 minus root 3i. Give your answer in the form of a plus bi, where a and b are an element of the real numbers. So the way I'm going to do this is I'm actually going to write this in polar form and then use the Moyers Theorem, and that'll get it down for me. So first of all, polar form, minus 1 minus root 3i. Now the square root, I'm just going to take that out for a minute because that'll be to the power of a half. So I'm going to write this in polar form first. So polar form, we need or which is our modulus, so that will be the square root of minus 1 squared plus the square root of 3, or minus the square root of 3 squared. So that's or is equal to the square root of 1 squared is 1, and minus root 3 by minus root 3 is 3, so 1 plus 3. So that's the square root of 4, so or is equal to 2. Then I need to find my angle. So if I just draw a quick sketch of what this complex number looks like. So it's minus 1 minus root 3. So minus 1 minus root 3 is down here. So I can make a little right angle triangle where that's 1 and that's root 3. So I want to find this angle here, and then I can find the full angle from the start of the x-axis there. So to find that angle, let's call it alpha. So alpha is equal to the tan of alpha is equal to opposite over adjacent, so that's root 3 over 1, which is root 3. If I then want to find alpha, so alpha is equal to the tan inverse of root 3, and the tan inverse of root 3 in radians is pi over 3. So the angle here, this small angle, is pi over 3. I actually want this full angle here from 0 degrees, so I'm going to add on an extra pi radians. So my angle theta is equal to pi over 3 plus pi, which is 4 pi over 3. So that gives me my or, and it gives me my theta. So now I can write my complex number in polar form. So to write it in polar form, it's or times, so that's or is 2 times cos of theta, which is 4 pi over 3, plus I sine 4 pi over 3. And now I'm going to bring in the square root again. The square root is to the power of a half. Okay, so now I have it in polar form. It's raised to a power, so now I can use the Moyers Theorem. So the Moyers Theorem says to expand this out, what you do is you bring the half out here, so it's 2 to the power of a half, and then it's going to be times the cosine of a half times the angle, so it's a half times 4 pi over 3 plus I sine of a half times 4 pi over 3. 2 to the power of a half, that's root 2. Cos of half times 4 pi over 3, that will be 2 pi over 3, so half times 4 over 3 is 2 over 3, so that's cos of 2 pi over 3 plus I sine 2 pi over 3. Okay, so now we can go into our calculator. Cos of 2 pi over 3 times root 2, that's going to give me minus root 2 over 2, and then sine of 2 pi over 3 times root 2, so root 2 sine 2 pi over 3 will give me minus root 6 over 2 I. Okay, so one more thing then just to take into consideration is that at the very start it was a square root, so if we're taking the square root of anything, it is actually plus or minus. Okay, so they're looking for both answers there, and then the solution that you get in the marking scheme, if you've seen it, is plus or minus. They factor out the 1 over 2, so they take out minus 1 over 2, which just is plus or minus 1 over 2 when you take out the minus 1 over 2 times root 2 plus root 6i. So you did need the plus or minus in that to get full marks on that question. Alright, on to question 2. So, solve the equation square root of 2x minus 1 plus the square root of x minus 1 equal to 5, and then verify your answers. So, if we want to solve an equation with square roots in it, what we need to do is isolate one of the square roots or one of the surds, and then square out both sides, and then you'll have a second one in this to re-isolate and then square out both sides as well. So I'm going to start by isolating this one. So it'll be the square root of 2x minus 1 is equal to 5 minus the square root of x minus 1. Now I'm going to square both sides. So that squared and that squared. When I square this side here, so the square root of 2x minus 1 squared gives me 2x minus 1. And then over here, well, squaring this out, so square the first is 25. Twice the product, so that'll be minus 10 square root x minus 1. And then the square of the second, so minus by minus is a plus, and x minus 1 squared is x minus 1. Next I'm going to re-isolate, so isolate this one now on its own, tidy it up, isolate this and go again. So I'm going to get rid of the 25, the x and the minus 1. So that'll be 2x minus 1 minus 25 minus x and plus 1 equals minus 10 square root of x minus 1. Tidying up this side here, I have 2x minus x is x. I have minus 25 minus 1 plus 1 is just minus 25. And that's equal to minus 10 root x minus 1. Now there's two ways you can go at this stage. So some people like to divide across by this minus 10 to fully isolate this. You can just leave it here and square it anyway. So for this case, I'm just going to leave it here and square both sides. So we square that side, we square that side. Right, so squaring this, x minus 25 to be squared. Square the first is x squared. Twice the product, so that's minus 25x. Twice that is minus 50x. And then square of 25 is minus 25 is going to be plus 625. On the opposite side then, that's equal to, now to square this, what you do is you square the number out in front and you square that. So minus 10 by minus 10 is 100, and then the square root of x minus 1 squared is x minus 1. So it's 100 times x minus 1. Now I have an equation, there's no square roots in it, it's going to be a quadratic equation. I'll just simplify it now and then I'll solve the equation. So getting everything to one side, x squared. Now this is 100x minus 100. So I'm going to write down my minus 50x plus 625 minus 100x and then plus 100. That's equal to 0. Tidying up there, x squared minus 50x minus 100x is minus 150x. 625 plus 100 is plus 725. That's equal to 0. So to factorize this here, factors of 725 that add up to give me 150 turn out to be minus 145 and minus 5. So my factors are x minus 145 times x minus 5. So that's equal to 0. So those are my two factors. Then that means our two roots are x equal to 145 and x is equal to 5. Now it does say to verify your answers, so we're going to have a look and see if both of them work. With this type of equation, when we have the square root, what tends to happen is you only get one of these answers working. So we'll check both of them just to see. So you sub in, we'll start with 5. So that'd be the square root of 2 times 5. minus 1 plus the square root of 5 minus 1, is that equal to 5? Question mark. So 2 times 5 is 10. 10 minus 1 is 9. The square root of 9 is 3. 5 minus 1 is 4. The square root of 4 is 2. So 3 plus 2 is equal to 5. Therefore, x equal to 5 is a solution. And then we'll try for the other one then. So for 145, so that'll be the square root of 2 times 145 minus 1 plus the square root of 145 minus 1. Is that equal to 5? Well, I think you should be able to see straight away that it's not equal to 5. So 2 times 145 is 290. 290 minus 1, 289. The square root of 289 is much bigger than 5, and we're adding on another number to it, so it is not equal to 5. Therefore, x equal to 145 is not a solution. Okay, so on to question B for this one. Solve the simultaneous equations. Log of x plus y is equal to 2 log x, and log of y is equal to log of 2 plus log of x minus 1, where x is greater than 1 and y is greater than 0. So what I'm going to do here is take a look at each one of these individually and see, is there anything that I can do with them to make them a bit easier. So the log of x plus y is equal to 2 times the log of x. Okay, so if I use my laws of logs, that means I can bring this 2 up into the power here in the x. So I get log of x plus y is equal to the log of x squared. Now I have the log of x plus y equal to the log of x squared. That means x plus y is equal to x squared. So x plus y is equal to x squared. Now I've made a much simpler equation. There's no longer any logs in it, and it's only in x's and y's. So we'll see if we can do the same thing with the other equation. So that's the log of y is equal to the log of 2 plus the log of x minus 1. So it turns out I can use a different law of log here. So to simplify this side, so I get the log of y. Now if I have the log of one number plus the log of another number, that's the log of the two numbers multiplied by each other. So 2 times x minus 1. And this gives me the same thing as the last time. I have log of y equal to the log of 2 times x minus 1. That means y is equal to 2 times x minus 1. And that's my other equation there in x and y. So I've gone from these two difficult looking equations with logs in them to these two equations here with no logs. They're just simple simultaneous equations that I should be able to solve easily. So to solve these, I'm going to substitute y equal to 2 times x minus 1 into here. So that's x plus 2 times x minus 1 is equal to x squared. I'm going to take everything to the right hand side and multiply out at the same time. So that'll be 0 is equal to x squared minus 2x plus 2 and minus x. So that's x squared minus 3x plus 2 is equal to 0. Okay, so to factorize this, x squared minus 3x plus 2 is equal to 0. Factors of 2 that add together to give you minus 3. That's going to be x minus 2 times x minus 1. That's equal to 0. So that means x is equal to 2 and x is equal to 1. Now we're told in the question x is greater than 1. So that means x cannot be equal to 1, so we discount that solution. Now if x is equal to 2, what is y equal to? Well, y is equal to 2 times 2 minus 1. 2 minus 1 is 1, 2 times 1 is 2, so my solution is x is equal to 2 and y is also equal to 2. Okay, so on to question 3. So solve the equation, the absolute value of x plus 2 is equal to the absolute value of x minus 13. So this is a modulus equation. To solve modulus equations, what we do is we square both sides. So I'm going to square this and square this. So that has the effect of saying x plus 2 squared is equal to x minus 13 squared. So squaring out both sides, square this. Square the first is x squared, twice the product is plus 4x, and square the last is plus 4. That's equal to over here. Square the first, x squared, twice the product, minus 26x, and the square of the last is plus 169. So this simplifies fairly nicely for me. I can subtract x squared from both sides, so that'll give me, or that'll get rid of them. And then if I take x's to one side, 4x minus 26x, that will be 30x. And then 169 minus 4, that's going to be equal to 165. So if I want to find x, then I just divide by 30 on both sides. So x is equal to 5.5. Okay, so part B in this, hence solve 3 to the power y plus 2 equal to 3 to the power y minus 13. So the hence here shows you the connection, and the connection is that 3 to the power y is equal to x. So what I can write down here is x is equal to 5.5, therefore 3 to the power of y is equal to 5.5. Now here I can just use logs to go and find y. So the log of 5.5 base 3 is equal to y. You can go straight into your calculator there for that. So log base 3 of 5.5 is equal to 1.551. Correct to 3 significant figures, so that will be 1.55. So y is equal to 1.55. Okay, so then on to part B. Find a range of values for k for which the equation k times x squared plus 1 minus 1 equals x times x plus 6 has real roots. So this is going to be a quadratic equation. If I just multiply everything out and simplify it, it'll be a quadratic equation. And then for us to find it having real roots, we use the b squared minus 4ac is greater than or equal to 0. So I'm going to start off by multiplying out here and making it into a quadratic equation. So multiply out there, you get kx squared plus k minus 1. And then I'm going to bring these over to the other side as well. So that'll be minus x squared and minus 6x is equal to 0. So I need to bring the x squares together. So I have kx squared minus x squared. That's k minus 1 times x squared. Then I have minus 6x and I have minus 1 equal to 0. Oh, sorry, I have a k there as well, so it's minus 1 plus k is equal to 0. So for real roots, I know that b squared minus 4ac is greater than or equal to 0. Well, A is k minus 1. B is minus 6. And C is minus 1 plus k, or k minus 1. So I'll do b squared minus 4ac. I'll let it greater than or equal to 0, and I'll solve for k. So b squared, that's minus 6 squared minus 4 times a, which is k minus 1, times c, which is k minus 1, greater than or equal to 0. Minus 6 squared is 36. K minus 1 times k minus 1 times 4. Let's leave the 4 there for the moment. K minus 1 times k minus 1 is k squared minus 2k plus 1, greater than or equal to 0. Now let's multiply in the 4. 36 minus 4k squared plus 8k minus 4 is greater than or equal to 0. Simplifying out here, I have minus 4k squared plus 8k. 36 minus 4 is plus 32, greater than or equal to 0. Now I have a common factor here of 4, but I'm also going to divide by minus as well. So I'm going to divide across by minus 4 so that the leading coefficient is positive. So that would be k squared minus 2k and minus 8. And then it's going to be less than or equal to 0, because if you divide by a negative number, you have to change the direction of the inequality sign. Okay, so we have a quadratic equation or inequality here now. To solve for k, I'm going to solve that as an equation. So I'm going to say k squared minus 2k minus 8 equal to 0. Factors of minus 8 that add to give you minus 2. It's going to be minus 4 and plus 2. So k minus 4 times k plus 2 is equal to 0. That means k is equal to 4 and k is equal to minus 2. So how do we know what values of k has real roots? We need to draw the graph. So just a sketch of the graph is enough. If I have here 4 and here minus 2, my quadratic looks like this. I want to know when is it less than or equal to 0. That means when is it below the x-axis. Well, it's below the x-axis in between minus 2 and 4. So k is greater than or equal to, because it's below or equal to the x-axis. So k is greater than or equal to minus 2, but less than or equal to 4. So all of these values in here, k has real roots. Any values outside of this region or this region, k does not have real roots. Okay, so question 4. A circular disc is divided into sectors whose acute angles form an arithmetic series. The first two sectors have acute angles of 3 degrees and 5 degrees respectively. Find the number of sectors in the disc. Okay, so we're told it's an arithmetic series. And we're told the first two angles. So what's happening is you have a circle disc, and the first angle is 3 degrees, the second angle is 5 degrees, the next angle will be 7 degrees, 9 degrees, and they keep getting bigger until you have a certain amount of sectors in the disc. We're asked to find how many sectors there are. Well, this it's an arithmetic series, so it's S of n is equal to 3 degrees plus 5 degrees plus 7 degrees plus 9 degrees, etc. until you get up. We don't know how high it goes. At the moment, we're going to figure out how high it goes. Well, I can write down a couple of things from my arithmetic series straight away. So that is that My first term, a, is equal to 3, and my common difference, d, is equal to 2. And I know that S of n, I know that the sum of the series must add up to 360 degrees, because that's how many degrees there are in a circle. So if I use my formula for S of n, so the formula S of n is equal to n over 2 times 2a plus n minus 1 times d. I have a, I have d, I have S of n, and I'm looking for n. So filling in everything I know, 360 is equal to n over 2 times 2 times 3 plus n minus 1 times d, which is 2. So that's 360 is equal to n over 2 times 6 plus 2. I can leave it as n minus 1 in brackets there for the moment. So let's multiply across by 2 to get rid of the fraction first of all. So 360 times 2 is 720. So 720 is equal to n times 6 plus 2n minus 2. I'm just going to multiply that out for now. Now I'll multiply across, multiply in by this n. So 720 is equal to 6n. Plus 2n squared minus 2n. Let's take everything to one side, so I'm going to take 720 away from both sides. I'll get 0 is equal to 2n squared. 6n minus 2n is 4n minus 720. That's equal to 0. So I can divide across by 2 to simplify even further. That'll give me n squared plus 2n minus 360 is equal to 0. So now I'm looking for factors of minus 360 that add up to give me plus 2. And the factors will be plus 20 and minus 18. So that'll be n plus 20 times n minus 18 is equal to 0. So that means n is equal to minus 20, or n is equal to plus 18. Well, we know that it has to be a positive number, because how many sectors are there in the disk? It has to be a positive number. You can't have negative amount of sectors in the disk. So that means minus 20 is discounted. So the answer is n is equal to 18. Okay, part B. The sequence u1, u2, u3 is defined by u1 is equal to 4 and u of n plus 1 is equal to minus 1 to the power of n times u of n plus 3. Find the values of u2, u3, u4, u5 and u6. Okay, so if we write down this part here first, so the u of n plus 1 is equal to minus 1 to the power of n times u of n plus 3. Now, the u of 1 is equal to 4. That's going to be important in a second. Let's try the u of 2. So n plus 1 is equal to 2. So that will be equal to minus 1 to the power of n. Now, if n plus 1 is 2, that means n is 1. And it means that the u of n is the u of 1, and the u of 1 is 4. So that's times 4 plus 3. So that means minus 1 to the power of 1 is minus 1. Minus 1 times 4 is minus 4. Minus 4 plus 3 is 1. So that means the u of 2 is equal to 1, or minus 1. Minus 4 plus 3 is minus 1. So we're just going to have to do that for each of them, for U3, U4, U5 and U6. So let's do the U of 3. So that'll be minus 1 to the power of n. Remember, n plus 1 is 2, or n plus 1 is 3, so that means n is 2, times the u of n, so times the u of 2, so times minus 1, and plus 3. So that's equal to minus 1 squared is 1, times minus 1, and plus 3. 1 times minus 1 is minus 1, minus 1 plus 3 is 2. So that means the u of 3 is equal to 2. Okay, how about the u of 4? We're just doing the same thing each time here now again. So that is minus 1 to the power of 3 times the u of n, which is the previous one, so times 2 plus 3. Minus 1 cubed is minus 1. Minus 1 times 2 is minus 2. So it's minus 2 plus 3, which is equal to 1. So the u of 4 is equal to 1. On to the u of 5. So the u of 5 will be equal to minus 1 to the power of 4 times the previous one, times the u of n, so times 1 and plus 3. Minus 1 to the power of 4 is plus 1. Plus 1 times 1 is 1. 1 plus 3 is 4. So the u of 5 is 4. So far I've got minus 1, 2, 1 and 4. I need to get one more, so I'm going to get the u of 6. So doing the same thing, that's minus 1 to the power of 5 this time, times the previous one, which is 4, plus 3. That's equal to minus 1 to the power of 5 is minus 1. Minus 1 times 4 is minus 4. Minus 4 plus 3 is minus 1. So the u of 6 is minus 1. Okay, so we can see that the sequence then is minus 1, 2, 1, 4. And then it continues on. Sorry, it started with 4. So 4, minus 1, 2, 1. Then it starts again. 4, minus 1, 2, 1. And it repeats. So it repeats every four times. That's going to be important for the next part, B part 2. So here's B part 2. Find the S of 2019, the sum of the first 2019 terms. Well, if I look at the first 4 terms, first of all, the first 4 terms were 4, minus 1, 2, 1. Well, what do they equal to? The first 4 terms, 4 minus 1 is 3, 3 plus 2 is 5, and 5 plus 1 is 6. So the sum of the first 4 terms is 6. Now, how many times do you have 4 terms in the 2019 terms? So what we do is 2019 divided by 4. That gives you 504 with a remainder of 3. So it'll be 504 times this. So that's 504 times 6 plus the first 3 terms. So plus 4 minus 1 plus 2. So 504 times 6 is 3024. 4 minus 1 is 3 plus 2 is 5. So that equals 3029. Okay, so on to question 5 then, our first differentiation question. So differentiate the function minus 2x squared plus 3x minus 7 from first principles with respect to x. Now, when people see first principles, they think, oh, it's going to take a long time. And it does, takes a couple of minutes to do it. But the good thing about first principles is that if you're able to differentiate, then you know what your final answer is going to be. So let's differentiate this just to see what our final answer is going to be. So to differentiate minus 2x squared, multiply down by the 2 and reduce the 2 by 1. So that'll be minus 4x, and then differentiate 3x, you get plus 3, differentiate 7, you get 0. So I know my answer is going to be minus 4x plus 3. Now, just be careful. If you write down minus 4x plus 3 and don't do it from first principles, you'll get 0 marks. So you need to actually do first principles. So the first principles formula is the f of x plus h minus the f of x divided by h, and we take the limit as h tends to 0. So the f of x plus h minus the f of x over h. Let's fill that in. So the f of x plus h is, I'm just going to replace x with x plus h. So that'll be minus 2 times x plus h squared plus 3 times x plus h minus 7 minus the f of x, so that's minus all of this. So that minus 2x squared will be plus 2x squared minus 3x and plus 7. And this is all going to be over h. So what I'll do is I'll multiply all this out, tidy it up, see what happens, and then I'll have a factor of h that will hopefully come out. So that's equal to minus 2. X plus h squared is x squared plus 2xh plus h squared plus 3x plus 3h minus 7 plus 2x squared minus 3x plus 7 all over h. Now if you see anything that cancels out, you can do that now. So I see plus 3x and minus 3x, so they cancel, they give me 0. And I see minus 7 and plus 7, so they cancel as well. So that just tidies it up and gets rid of things like that straight away. Now I still have my plus 3h and my plus 2x squared, so don't forget about them. Let's multiply out this bracket here. So that's equal to minus 2x squared plus 4xh plus 2h squared plus 3h plus 2x squared. So over h, is there anything now that cancels again? Well, plus 2x squared and minus 2x squared will both cancel. Now I'm left with everything on the top line having a h in it. So what I can do is I can take h out as a common factor. That leaves me with 4x plus 2 plus 3. 2h rather, and plus 3. And that's over h. Okay, so I'm just after noticing that I forgot to bring my minus in here. That's a minus 4hx, and that is a minus 2h squared. So that means this is minus 4x and minus 2h. Okay, so anyway, the h and the h, they cancel out. That gives me minus 4x minus 2h plus 3. Now I'm going to get the limit of that as h tends to 0. So the limit as h tends to 0 of minus 4x minus 2h plus 3, that's going to go to 0. So that gives me minus 4x plus 3, which is what I know is the right answer. So just for that question, make sure you do first principles. If you don't do first principles, you'll get 0 marks, even though it's something that's very easy to differentiate by rule, but if you don't do first principles, you won't get the marks. So part B, given that y is equal to e to the power of x cos kx, find dy dx and d2y dx squared. So find the first derivative and the second derivative. So y is equal to e to the x cos kx. That's going to be a product rule, so it'll be e to the x and cos kx. So I'm going to let u equal to e to the power of x, and I'm going to let v equal to cos kx. So when you differentiate u, you get du is equal to e to the x. You differentiate e to the x, you get e to the x, and dv, differentiate cos kx. Well, cos becomes minus sign, and when you're differentiating a trig function with a constant in front of the x, that constant comes out in front, so it'll be minus k sine kx. So differentiate cos kx, you get minus k sine kx. So then dy dx is equal to u dv dx plus v du dx. Okay, so this is du dx, if you like, and this is dv dx. So that's equal to u, so that's e to the x times dv dx, which is this one here, minus k sine kx, plus v, which is cos kx, times du dx, which is times e to the power of x. What we can do there is we can take a common factor of e to the x, e to the power of x, and then leave this stuff inside the brackets. I'll write this one first because that's positive, cos kx minus k sine kx. So that is the first derivative, dy dx. Second derivative, it's going to be another product rule. That's u, that's v. So to find the second derivative, I'm going to let u is equal to e to the power of x. That means du dx is also equal to e to the power of x. And I'm going to let v equal to cos kx minus k sine kx. Let's differentiate that one. So dv dx cos kx, so differentiate cos, again you get minus sine, that'll be minus k sine kx. When I differentiate sine, I get cos, my minus is already there, and remember I need to multiply out in front by this k, so k by k is k squared cos kx. So my second derivative, I'm using the same formula here, the product rule formula, so it's u dv dx plus v du dx. Now I'm going to kind of cheat a little bit here. I know that u and du dx are both the same, so I'm going to keep that as a common factor straight away. So the second derivative is equal to the common factor e to the power of x times the sum of these two. So that'll be cos kx minus k sine kx, and minus another k sine kx is minus 2k sine kx, and then minus k squared cos kx. Okay, so then on to the last part of question 5. So hence find the values of k for which the second derivative minus 2 times the first derivative plus 2y is equal to 0. So we'll have to write down our derivatives as we had them. So the second derivative was e to the power of x times cos kx minus 2k sine kx minus k squared cos kx minus 2 times the first derivative. The first derivative was e to the power of x times cos kx minus k sine kx, and then plus 2y is equal to 0. Of course, we know that y was given to us in the first place, so it's plus 2 times what y was. Y was e to the x cos kx, so that's equal to 0. So this looks like a very messy equation, and it is, so we just have to work through it and see, is there any way we can simplify it. So the first thing we can do is we can take out a common factor from all three of them, is e to the x. So e to the x is common to all of them. So that's e to the power of x times this minus 2 times this and plus 2 times that. So that'll be cos kx minus 2k sine kx minus k squared cos kx minus 2 times cos kx minus k sine kx and plus 2 cos kx. And that's equal to 0. So we've made it a little bit simpler so far by factoring out the e to the power of x. So now if we have a look and see what we have in here, we might have things that can cancel out. We have minus 2k sine kx, and over here we're going to have minus 2 times minus k sine kx. So I might just multiply out these this bracket here first, and then it might be easier to see. So e to the power of x times cos kx minus 2k sine kx minus k squared cos kx minus 2 cos kx plus 2k sine kx and then plus 2 cos kx equal to 0. So I have minus 2 sine kx here, and I have 2k sine kx there. So those two will cancel out with each other. And here I have minus 2 cos kx, and here I have plus 2 cos kx. So they will also cancel out with each other. So it gets a lot easier for me now. I have e to the power of x times cos kx minus k squared cos kx equal to 0. So let's have a look in here, and we can see that there's a common factor in here. So cos kx is common to both of them. So that's e to the power of x times the cos of kx times 1 minus k squared. So if I take cos kx out of here, it's just 1. If I take cos kx out of here, it's minus k squared, like that. And that's equal to 0. So now I pretty much have 3 factors. So I have e to the power of x times the cos of kx times 1 minus k squared. And that's equal to 0. So I'm only interested in what are the values for k. So I'm not worried about what these x's are. So if I divide both sides by e to the power of x times cos of kx. And I'll do the same on here, e to the power of x times cos of kx. Well, on this side it doesn't matter, 0 divided by that is 0. But on this side, those will cancel out. So I end up with 1 minus k squared is equal to 0. So k squared is equal to minus 1. Sorry, minus k squared is equal to minus 1. So k squared is equal to 1. So if k squared is equal to minus 1, then of course k is equal to plus or minus 1. Okay, so on to question 6, which is a financial maths question. So Tara is planning for her retirement and wishes to calculate the value of the pension fund she requires when she retires. She wants to have a pension fund that could, from 1 month after the date of her retirement, give her a monthly payment of €2,000 for 25 years. Assuming the fund will earn an annual equivalent rate of 3.5% over the period of the payments. Show that the rate of interest compounded monthly, which is equivalent to an AER of 3.5%, is 0.287%. So we use our compound interest formula here. So F is equal to P times 1 plus or to the power of T. In this case, if we were to put in €1, we would end up with 1.035 euros. And then we want to calculate what our rate would be, so our or, if we had 12 months. So that's 12 months, the rate will give us 1.035, which is the equivalent of 3.5%. So to get this, we're going to get the 12th root of 1.035. So it's the 12th root of 1.035 is equal to 1 plus or. And we want or, so or is equal to this minus 1. So it's the 12th root of 1.035 minus 1. So on your calculator, the way you'd write that is the 12th root of 1.035 and minus 1. That's going to be 2.87 by 10 to the minus 3, which is 0.287%. So we can say or is equal to 0.287%. Part 2. Find correct to nearest euro the value of the pension fund that Tara requires when she retires. So her pension fund, she wants to have 25 years, which is 300 months. So she needs 300 months of €2,000 a month. So she's getting €2,000 a month for 300 months. But we have to take into account the present value of that €2,000 at the time of retirement. So in month 1, she gets €2,000. Now the present value, so I'm just going to write present value here of that is going to be 2,000 divided by 1.00287 to the power of 1. So she gets this €2,000 1 month later. So 1 month later, it's earned interest of 0.287%. So that's its present value at the date of retirement. In month 2, she's going to get €2,000, but it has a present value of 2,000 divided by 1.00287 to the power of 2. So she's earned interest on it for 2 months, etc. And this will continue on until the 300th month, which will be €2,000. And her €2,000, the present value of that at the time of retirement is 2,000 over 1.00287 1.00287 to the power of 300. So what we have here is a geometric series. Okay, the first term is A is equal to 2000 over 1.00287. And we have a common ratio, or of 1 over that 1 over 1.00287. And our n, our number of repayments, or a number of terms in this case, is 300. So if we do the sum of our geometric series here, we'll find out how much that is worth at the start of her retirement. Okay, so our SN formula, SN is equal to A times 1 minus or to the n over 1 minus or. So we want the S of 300. So the S of 300 is 2000 over 1.00287 times 1 minus our or 1 over 1.00287. That's to the power of 300. And then this is all over 1 minus our or, which is 1 over 1.00287. So that whole thing there can go into your calculator, and if you are careful typing it in and you keep your brackets where they're supposed to be and get everything right, you'll get a value of 401,908 euros and 87 cents. It wanted it correct to the nearest euro, so we can round that up to 909. So that's equal to 401,909 euros. Okay, and on to part B for this then. Tara decides that she wants the pension fund to give her a fixed monthly payment indefinitely. So assuming the fund will continue to earn an AER of 3.5%, find the amount of each payment correct to the nearest cent. So what Tara wants here is, instead of 2,000 euros a month for 300 months, she wants to know how much can she get indefinitely. So that means continuing as long as she lives, even so that the money she has, it's earning 3.5%, and she'll be able to get this amount forever. So this is a sum to infinity, and the sum to infinity, we know that she has 401,909 at the start of her retirement. So that's the sum that it will add up to. The first term, the money that she's going to get is 1 month later is X, and it's divided by 1.00287, which is our monthly interest rate. So she's getting a payment of X. This is 1 month later, so we have 1 month of interest there as well. So the present value of her first payment is this here. Our common ratio is going to be the same as before, 1 over 1.00287. So we can do our sum to infinity. Our formula for the sum to infinity is A over 1 minus or. So our sum to infinity, that'll be 401,909 is equal to A, which is X over 1.00287 divided by 1 minus or, and or is 1 over 1.00287. Okay, so working through this to find X, well, if I multiply both sides by this denominator here, that'll be 401,909 multiplied by 1 minus 1 over 1.00287. That's equal to x over 1.00287. And then to get x on its own, just multiply across by that again. So it's 4,01909 times 1 minus 1 over 1.00287 times 1.00287 is equal to x. So if you type that into your calculator, and just be careful of brackets and all that, you'll get an answer of x is equal to €1,153.48. Okay, so on to section B, question 7. So part A, a rectangle has 4 vertices, 2 of which are on the positive x-axis at x1 and x2, and the other 2, which are x1y and x2y, are on the lines y equal to 2x and y equal to minus 3x plus 6 respectively. Find x1 and x2 in terms of y. So for this, we're given a bit of a sketch here, so I'm just going to finish off the sketch. We have 2 x values, so this is x1 and x2. Those are our x values, and we're told that we have 2 lines. One of them is drawn in for us, that's y equal to 2x. The other one is y equal to minus 3x plus 6. So that has a y-intercept of 6, let's say that's somewhere up here, and then a slope of minus 3, so it's going down something like that. Okay, it's just a rough sketch, it doesn't need to be too accurate. And a rectangle is then going to look something like this. Okay, so rectangle, and here are the 2 points that they're referring to, x1y and x2y, and that's the height there, that's y. So if we take our first point there, x1 y, and that's an element of this line here, y is equal to 2x. Well, we can sub in x and y, so y is just y, x1 is x, so y is equal to 2 times x1. We want to isolate x1 on its own, so x1 is equal to y over 2. Now for the other one, this point here, so that's x2y. Well, x2y is on the line, this line here, y is equal to minus 3x plus 6. So that's y is equal to minus 3x2 plus 6. I want to isolate x2. So take 6 from both sides, y minus 6, and then divide both sides by minus 3. Divided by minus 3. That'll give me x2 on its own. I can just then take the negative sign up to the top line to get x2 is equal to 6 minus y over 3. Part B then, find the area of the rectangle in terms of y. So area is equal to length by width. I have a length or a width of y. My length is the distance from x1 to x2, so that would be x2 minus x1. So that's x2 minus x1 times y. So that's 6 minus y over 3 minus y over 2 all times y. So we want to simplify that and make it as simple as possible. So lowest common denominator would be 6. So multiply this one by 2 and this one by 3. That would be 2 times 6 minus y over 6 minus 3y over 6 all times y. So that would be 12 minus 2y minus 3y all over 6 is equal to y. Times y multiplied by y. So then multiplying in the y, so that's 12 minus 5y times y, so that's 12y minus 5y squared over 6. So that would be the area of the rectangle in terms of y. And part 3 then, hence find the maximum possible area of the rectangle and justify your answer. So for the maximum possible area, if we differentiate it and let it equal to 0, that'll give us the maximum area. So dA dy, this is when we're differentiating a. So dA dy is, okay, so I'm going to take my a first of all, which is 12y minus 5y squared over 6. I'm going to simplify it. I'm going to divide the 6 in. So 12 divided by 6 is 2y, and then minus 5 over 6y squared. This is just going to make it easier for me to differentiate. So dA dy, so differentiating this with respect to y, differentiate 2y and you get 2. Differentiate minus 5 over 6y squared, that'll be minus 10 over 6y. So we're going to let this equal to 0 and solve for y. So minus 10 over 6y is equal to minus 2. So y is equal to minus 2 divided by minus 10 over 6. And minus 2 divided by minus 10 over 6. So we can go minus 2 divided by minus 10 over 6. And that should give us 6 over 5, or 1.2. So that's 1.2 square units because it's area. If we want to justify this, we go ahead and take the second derivative. So d squared a dy squared. So that would be differentiating this one here. Differentiate 2, you get 0. Differentiate minus 10 over 6y, you get minus 10 over 6. And minus 10 over 6 is less than 0. Therefore, we have a local max, which means that it is the maximum area for the rectangle. Right, so on to part B then. A corridor of width 2 meters turns 90 degrees onto another corridor of width w, as shown. A ladder of length pq, so here's the ladder, has length pq. It's actually given, the length is given 5 meters, is to be carried horizontally around the corner. And let this angle here, PQO, equal to theta. So that's the angle theta there. We're asked to find RS in terms of theta. That is this angle, or this length here. So RS, it would be ideal if I could use this triangle here. So let's see if we can do anything with that. Well, this angle theta is on a vertical line, and this is a vertical line, so we can actually do alternate angles there, and this is also theta. So now I have a right angle triangle, with theta and or P and or S, sorry, or S is what I'm looking for, this one, or S. So what I'm going to do then is the tan of theta. So I want to include RS into here. So I'm going to do tan, which is opposite over adjacent. So tan of theta is equal to the opposite, which is RS, over the adjacent, which is 2. So I want to get RS in terms of tan theta, so I'll just multiply across by 2 to show that the length RS is equal to 2 tan theta. Next part there is find PO in terms of theta. Well, PO in terms of theta, I have 90-degree angle here. I have PO, which is the side I'm looking for there, and I also have QP here. So I know QP is 5, so I can use that similar to the one before. So I can use this triangle. Maybe I'll just draw it like this. So that's 5. That's my right angle. This is POQ, Q, and that's theta. So I want this one in terms of theta, so I'm going to use sine, which is opposite over hypotenuse. So sine of theta is equal to the opposite, which is PO, over the hypotenuse, which is 5. Again, I want PO isolated, so that means the length PO is equal to 5 sine theta. Part 3 then, hence find the width of the second corridor, W, in terms of theta. So want to know this width here. Well, we've just found this one, or RS, we have that up here. We've just found this one, RS, that's here, and we've also found PO, that's up here. So W is just PO minus RS. So W is equal to PO minus RS. So that's equal to, PO was 5 sine theta and RS was 2 tan theta. So W is equal to 5 sine theta minus 2 tan theta. So part 5, find in meters the minimum width of the second corridor that will allow the ladder to be carried horizontally around the corner. Give your answer correct to 2 decimal places. So what I have is, I have W is equal to 5 sine theta minus 2 tan theta. So I want the minimum width, so I want to minimize W. So I'll minimize that when I find the derivative and let it equal to 0. So the derivative of W, so that's dW with respect to theta. So dW d theta, I need to differentiate this with respect to theta. Well, if I differentiate 5 sine theta, I get 5 cos theta. And if I differentiate 2 tan theta, well, the derivative of tan is secant squared, so that'll be minus 2 secant squared theta. And now I need to let this equal to 0. So I have a 5 cos theta minus 2 sec squared theta equal to 0. I want to try and solve for theta. So let's go 5 cos theta is equal to 2 secant squared theta. Now secant squared I know is 1 over cos squared. So that's 5 cos theta is equal to 2 times 1 over cos theta. So that's 2 over cos squared theta. I can multiply across here by cos squared theta to get this all the causes together. So cos squared times cos is cos cubed. So it'll be 5 cos cubed theta is equal to 2. And then divide by the 5. So cos cubed theta is equal to 2 divided by 5. Now I don't want, or I can't find cos cubed, I can't find theta straight away with cos cubed. So I need to take the cubed root of both sides. So cos theta is equal to the cubed root of 2 over 5. And now if I want to find theta, it's the cos inverse of the cubed root of 2 over 5 is equal to theta. So if you type that into your calculator, you get 42.54 degrees. So my angle is 42.54 degrees. So how wide is my corridor? Well, if I take this angle 42.54 and sub it into here, that'll give me the width. So W is equal to 5 sine 42.54 minus 2 tan 42.54. So you can type that straight into your calculator as it is, and we'll get approximately 1.55 meters. So W is 1.55 meters. Okay, so on to question 8 here. A disposable water paper cup is in the shape of an inverted right circular cone as shown. The height of the paper cup is 80 millimeters and the diameter is 50 millimeters. That would be the diameter at the top. The cup is filled with water to a depth of h millimeters. However, the cup is leaking from its vertex at a constant rate of 8 millimeters or cubic millimeters per second. Given that r is the radius of the free surface of water, that would be the surface of the top of the water up here, express h in terms of r. Okay, so for this I'm going to draw a couple of triangles. So this is kind of a cross section of the cup. This would be 25 up there because the diameter is 50. The total height here would be 80. And let's say this here is our height, h. Okay, and then this would be our radius, r. So I have two similar triangles here. So if I do r over h, that's the same as 25 over 80. So r over h is equal to 25 over 80. And I want to write h in terms of r, so I want to isolate h. To isolate h there, I'm going to multiply across by h. That'll give me r is equal to 25h over 80. I'm going to multiply by 80. That'll be 80 r is equal to 25h. And then divide by 25 to get 80 over 25 times r is equal to h. I can simplify that, divide both by 5, so 5 into 25 goes 5 times, 5 into 80 goes 6 times, so I can simplify it as h is equal to 16 over 5 r. Part 2, find the volume of the water in the paper cup in terms of r. So the volume of the water for a cone, the volume for a cone is equal to 1/3 pi r squared h. So I have h, I just need to fill that in, so v is equal to 1/3 pi r squared times 16 over 5 r. So 16 over 5 times 1/3 would be 16 over 15, and then r by r squared would give me r cubed. So that would be 16 over 15 pi r cubed. And we'll just leave it in terms of pi because it'll be more useful for us in terms of pi. And they're asking for volume here, so it is millimeters, cubic millimeters. Part 3, find the rate at which the radius of the free surface of the water is decreasing when the depth is 48 millimeters, and give your answer in terms of pi. So the rate at which the radius is decreasing, so that is d or dt. Okay, the radius decreasing with respect to time. Now, I can't find that directly, so I'm going to have to use my chain rule to find that. So dr dt is dr dv times dv dt. So if I can find both of these here, then I can find dr dt. Now, I know what dv dt is because that's given to me at the start. I'm told that the volume is decreasing by 8 with respect to time. So dv dt is equal to minus 8. So that is given to us already. Now I want to find dr dv. Now, I can't find the rate of change of the radius with respect to volume, but I can find the rate of change of the volume with respect to radius. So I can find dv dr, and then I can just invert it. So dv dr, how I'm going to find that is I'm going to use volume. Volume is equal to 16 over 15 pi r cubed. I found that from the last one. So if we differentiate that, we get dv dr. So dv dr is equal to multiply down by the 3. So 3 times 16 over 15 is 16 over 5 pi r squared. So that's dv dr. I want to invert that to get dr dv. So that means dr dv is equal to 5 over 16 pi r squared. So now I have dr dv and I have dv dt. So I can put them together now. Dr dv is minus 8, and that's times dv dt, which is 5 over 16 pi r squared. So let's put that together. Minus 8 times 5 is minus 40 over 16 pi r squared. And simplifying that down, we can divide above and below by 8. That would give us minus 5 over 2 pi r squared. So that's dr dt, and I want to know the rate that it's changing when the water depth is 48 millimeters. So I need the height to be 48 millimeters. So the height I have in terms of r from the last, or from section part 1, is 16 r over 15. So I'm going to isolate r. So if I isolate r there, r is equal to 5h over 16. I want my h to be 48. So that would be r is equal to 5 times 48 over 16. So r is equal to 15. So my radius is going to be 15. So I'll sub in 15 into this here to find out what the rate the water is or the rate at which the radius is decreasing. So subbing r equal to 15 into this here. So minus 5 over 2 pi r squared. When r is 15, it's minus 5 over 2 pi times 15 squared. And they want it in terms of pi, so you can put it into your calculator. Your calculator should give it to you in terms of pi. So that's 1 over 90 pi, and that's millimeters per second. And I just forgot the minus there. So obviously it's decreasing, so it's minus 1 over 90 pi millimeters per second. And finally, part 5, hence find the rate at which the area of the free surface of the water is decreasing at the same depth. So the depth being 48 millimeters again. So we want the rate at which the area of the water is decreasing. So that is dA dt. So dA dt, again, we can't find it directly, so we're going to have to use the chain rule. So that's dA dr times dr dt. Dr dt. So dA dr is the rate at which the area is changing with respect to the radius. So area of the, I suppose, the surface of the water is pi r squared. So dA dr is equal to 2 pi r. That's the first half there. And then dr dt we actually found in the last one. So dr dt was up here, and that's minus 1 over 90 pi. So that then there is 2 pi r multiplied by minus 1 over 90 pi. So that's equal to minus 2 pi r over 90 pi. The pi's will cancel. 2 into 2 is 1, 2 into 90 is 45. So that's equal to minus r over 45. And then I want this at a depth of 48. So I want this at a depth of 45, or 48 rather. I found from in the last section that at a depth of 48, r is equal to 15. So if I just sub in 15 for that, that'll be minus 15 over 45. So that's equal to minus 1 over 3 square millimeters per second. Okay, so on to part B. Part B says the number of people infected by a viral infection in a town can be modelled by the function n is equal to 20,000 e to the power of 2t over 199 plus e to the power of 2t, where t is the time in days when the infection first appears. So how many people are initially infected? So that would be t equal to 0. So n is equal to 20,000 e to the power of 2 times 0, so that's just e to the power of 0, over 199 plus e to the power of 0. So that's that there is equal to 1, that there is equal to 1, so that's 20,000 divided by 200, which is equal to 100. So initially there are 100 people infected. Part 2, find an expression for t in terms of n and hence deduce the range of values for n. So I want to write t in terms of n. This initial thing that I have here is n in terms of t, so basically I want to isolate t on its own and it'll be in terms of n. So n is equal to 20,000 e to the power of 2t over 199 plus e to the power of 2t. So first thing I'm going to do is get rid of the fraction, so multiply across by 199 plus 2t. So that gives me n times 199 plus e to the power of 2t is equal to 20,000 e to the power of 2t. Okay, let's multiply out the brackets there. So I get 199n plus plus n times e to the power of 2t, and that's equal to 20,000 e to the power of 2t. So I want n in terms of t. So next we'll go is 199n is equal to 20,000 e to the power of 2t minus n times e to the power of 2t. Now I can factor out e to the power of 2t on that side, so e to the power of 2t times 20,000 minus n, and that's equal to 199n. Now I can isolate t on its own anyway by dividing by this here, so 199n divided by 20,000 minus n, that's equal to e to the power of 2t. So e to the power of 2t is equal to this. So if I take the natural log of this, it'll be equal to 2t. So the natural log ln of 199n over 20,000 minus n is equal to 2t. And then to get t on its own, divide by 2 or multiply by half. So t is equal to a half natural log of 199n over 20,000 minus n. So that is n is that is now t is in terms of n. Now the second part is hence deduce the range of values for n. So the range of values for n is the number of people who are infected. So the number of people infected must be greater than 0. The time must be greater than 0. So if t is greater than 0 and n is greater than 0, that means 199n is greater than 0. It also means that 20,000 minus n is greater than 0. So 20,000 minus n is greater than 0. So 20,000 is greater than n. N is less than 20,000 and n is greater than 0. So n is greater than 0 and less than 20,000. Okay, part 3, by finding dt dn, show that the n dt, the rate at which the infection is increasing, can be written as n times 20,000 minus n over 10,000. So I have t is equal to a half times the natural log of 199n over 2,000 minus n. We have that from the last section, or 20,000 minus n from the last section. I can use my laws of logs just to expand this here. So t is equal to a half times the natural log of 199n minus the natural log of 20,000 minus n. So I'll go ahead and differentiate this. So dt dn. Now, it's by finding dt dn, I'll find dn dt. So whatever answer I get for dt dn, I just invert it and it should be equal to that there. So dt dn is half times, when you differentiate the log of 199n, you get 1 over 199n times 199. And then when I differentiate the log of 20,000 minus n, it's minus 1 over 20,000 minus n times minus 1. So let's simplify that there as much as we can. So that's equal to half times 199 times this will just be 1 over n, and then minus 1 times this would be plus 1 over 20,000 minus n. So we'll add these two fractions together in here. We have to get the common denominator. The common denominator is n times 20,000 minus n. 1 over n. To get to this denominator, I need to multiply 1 by 20,000 minus n. 20,000 minus n. To get 1 to have this denominator here, or sorry, to get this one to have this denominator here, I multiply by n, so that's plus n. So minus n plus n will cancel out. So coming up to the top here, that's equal to half times 20,000 over n times 20,000 minus n. Okay, so half of that is 10,000, so that's equal to 10,000 over n times 20,000 minus n. And I want n times 20,000 minus n over 10,000, which is that inverted, which is dn dt. So therefore dn dt is equal to n times 20,000 minus n over 10,000. And the last part of this question then, hence find the number of people infected when the infection is spreading most rapidly. So when the infection is spreading most rapidly, the number of people infected, the maximum will be when dn dt is equal to 0. So dn dt is equal to 0. So that is n times 20,000 minus n over 10,000 is equal to 0. Multiply across by 10,000 to get n times 20,000 minus n equal to 0. Multiply out the brackets, 20,000 n. So rather than multiplying out the brackets, I can divide by n, divide across by n to get 20,000 minus n is equal to 0. So then add n to both sides, n is equal to 20,000. So the number of people that's infected when the infection is spreading most rapidly is 20,000. Right, so on to question 9, which is the last question. Question 9, the area bounded by the curve y equal to x squared and the line y equal to 4 is divided into two regions of equal area by the line y equal to a, where a is greater than 0 but less than 4. Use the trapezoidal rule to estimate the area enclosed between the curve and the line y equal to 4. So here's the line y equal to 4, here's the curve. So these points here, y equal to x squared and y equal to 4, this will be 2 and this will be minus 2. Those are the x values. Then the height, I'm going to have to break this up into different regions. So trapezoidal rule will break it up into 4 different regions there. We've 1, 2, 3, 4, and they'll all have different heights there. The height of this h here is going to be 4 minus x squared, minus whatever the x squared is. So the height is 4 minus x squared. H is equal to 4 minus x squared. So using the trapezoidal rule there, I'm going to say x is from -2, then it's going to be -1, then 0, then 1, then 2. These are my heights. So I want 4 minus x squared to get my different heights then. So 4 minus x squared, my height will be 0. That's 4 minus 4. 4 minus x squared is 4 minus 1, so my height is 3. Here it's 4 minus 0, so it's 4 minus 0, my height is 4. Here 4 minus 1, so my height is 3. And here it's 4 minus 2, so my height is 2. Sorry, 4 minus 2 squared, 4 minus 4, so my height is 0. So I have my different heights here. They're 0, 3, 4, 3, and 0. So let's use the trapezoidal rule then. That's h over 2 times y1 plus yn plus 2 times y2 plus y3 plus y4 this yn is actually just y5, so we have 5 different heights here. So we can fill in that's that's h there, which I suppose we called this h or height, but h is the distance between the heights, so that's 1 over 2. Y1 is 0, y5 is 0, plus 2 times 3 plus 4 plus 3. And that will give us an area of 10 units squared. Part 2, find the actual area enclosed between the curve and the line, and hence find the percentage error in your answer to part A. So the actual area, so what we'll have to do here is we'll have to find the area underneath the curve, which is this area here, and then if we find the big area of the rectangle and take the small area here that we find through integration from the area of the rectangle, that'll give us the area here. So let's find the area under the curve. So that is the integral from -2 to 2 of x squared dx. So integrate x squared dx, you get x cubed over 3. And we want to evaluate that between -2 and 2. So that'll be equal to 2 cubed over 3 minus -2 cubed over 3. That's equal to 8 over 3 minus 8 over 3. So that's 8 over 3 plus 8 over 3, which is 16 over 3. So that's the area underneath the curve. The area of the rectangle, well, it's actually a square, so it went up to the line y equal to 4, and it had 4 units across, so the large area is 16. Area is equal to 16. So then the area under the curve is 16 minus our 16 over 3, which is equal to 32 over 3. So that is our area under the curve. Area under the curve, or the area between the line and the curve. So to find our percentage error then, percentage error is equal to 32 over 3 minus 10, which is 2/3. That's our error rather than our percentage error. So our error is 2/3. Our percentage error then is going to be 2/3, which is our error, divided by what we should have got, which is 32 over 3. And then we multiply it by 100 to get it into a percentage, and that'll be equal to 6.25%. Okay, so part 3, hence show that a cubed is equal to 16. Remember, a was a line that was intersecting, here somewhere. Two regions enclosed by the line y is equal to a. So y is a line that goes across somewhere here. So let's draw just a little sketch out here so that we can see it again. So I'm going to draw this sketch. Here it is. This is the curve, y equal to x squared. Here's the line, y equal to 4. And here's the line, y equal to a. So we want to find what are the x coordinates here of this line, y equal to a. Well, if y is equal to x cubed, then if I want to find what the values are for x there in terms of a, it's actually going to be the square root of a and minus the square root of a. So now I can integrate to get this area here, the area underneath this curve from minus root a to plus root a, that is under the line y equal to a. So I'm going to get the integral from minus root a to root a of x squared dx. So again, the integral of x squared is x cubed over 3, and I'm going to evaluate that from minus root a to root a. So that would be equal to root a cubed over 3 minus root a cubed over 3. So that, if you simplify it, is 2a root a over 3, and that's square units. So that's the area underneath the curve, underneath the curve when it's bounded by the line y equal to a. Okay, so what about the area of between the line y equal to a and the curve x squared? So this area here. Well, I'm going to find the area of that rectangle there. So that rectangle, if I write it out, has a height of a and a length of 2 root a. So the area of that is going to be 2a root a. 2a root a. So that's the area of that rectangle there, which is this one here. So if I then want the area here in between that line and that curve, I'll take away this area that I just found. So the area is equal to 2a root a minus 2a root a over 3. So then if I want to write these, or if I want to do this subtraction here, I need to write them with the same denominator. So if I put that one over 3, I've multiplied by 3 on the bottom, I need to multiply by 3 on the top. So I'm going to put a 3 up there as well. And now I can add these together. So it's 3 times 2 is 6. 6a minus 2a is 4a root a over 3. So that's the area between the line y equal to a and the curve y equal to x squared. Now what we also need to know is that we're told that the line y equal to a splits these areas in two. So the area that we found earlier on is twice the size of this area. So we can say this area is half of the area we found before, half of the 10 2/3. So that's also equal to a half of the area 10 and 2/3, or 32 over 3. So half the area of 10 and 2/3, which is equal to 16 over 3. So that area there, 4a root a over 3, is equal to 16 over 3. So we can just solve this now. Multiply across by 3, you get 4a root a is equal to 16. We can divide across by 4, so a root a is equal to 4. I want to get rid of this square root sign, so I'll square both sides. Squaring a will give me a squared. Squaring root a will give me a, and squaring 4 will give me 16. And then a squared times a is a cubed. So a cubed is equal to 16, which is what they asked me to show. Hence show that a cubed is equal to 16. Right, so part B. A plant is kept at a constant temperature in a greenhouse. The rate of growth of the plant depends only on the length of day and can be modelled using the function dH dt is equal to k times 12 plus 3 cosine 2 pi over 365t, where h of t is the height of the plant measured in centimetres. T is the number of days after 21st of June, i.e. t is equal to 0. And then k is a constant, and 2 pi over 365t is expressed in radians. The height of the plant on the 21st of June is 84 centimetres, and the height of the plant on 4th of September, which is 75 days later, is 91.5 centimetres. Use integration to show that k is equal to 0.007, correct to three decimal places. So they want us to use integration, so we're going to go ahead and integrate our function up here. So that is the integral of k times 12 plus 3 cosine of 2 pi over 365 t dt. So when I integrate this, what I get is k is a constant, so that doesn't change. It's k times integrate 12, you get 12t, and integrate 3 cosine of 2 pi over 365t, you get 3 cosine 2 pi over 365t divided by this here again. So that'll be 3 sine 2 pi over 365t, all divided by 2 pi over 365. And then, of course, because it's integration, we have our constant of integration plus c. Now, we're told that at t equal to 0, h is equal to 84. So if I sub in 0 into here, my answer is 84. So I can say 84 is equal to k times what's in the brackets plus c. Now what's inside the brackets turns out to be 0, because if I sub in 0, 12 times 0 is 0. 3 sine 2 pi over 365 times 0. So this is 0. Sine of 0 is 0. So that whole fraction there is 0. So it's k times 0 plus c. That means that c is equal to 84. So now instead of having my c up here, I have plus 84. Now the other bit of information that I'm told is that at t equal to 75, h is equal to 91.5. So if now I sub in t equal to 75, I get the answer of h is 91.5, and that will give me my k. So 91.5 is equal to k times 12t, t is 75, plus 3 sine 2 pi over 365 times 75 all over 2 pi over 365, and then plus my constant, which was 84. So if I take 84 from both sides, my 91.5 becomes 7.5, and my 84 is gone. So now to get k is equal to 7.5 divided by what was in the brackets there. So you can go to your calculator and figure out what that is. 7.5 divided by all of this, and you get k is equal to 0.007, correct to 3 decimal places. And part 2, find the expected height of the plant after 1 year, which is 365 days. So I'm just going to find the h of 365, which is subbing in 365, so of 0.007 times 12 times 365 plus 3 sine 2 pi over 365 times 365 over 2 pi over 365 plus my 84. So if you can sub all that straight into your calculator, you get the h of 365 is equal to 114.66 centimeters. Okay, so on to the last part of the last question in this mock exam. Find the average height of the plant over the period of 1 year and give your answer in centimeters correct to 2 decimal places. So this is the average height formula. So the average height is 1 over b minus a times the integral from a to b of our function ht dt. So a and b in this case are going to be 0 and 365. So the average height is 1 over 365 minus 0 times the integral from 0 to 365 of 0.007 times 12t plus our 3 sine 2 pi over 365 t all over 2 pi over 365 and plus our 84. Okay, so working through that, there's a bit of work just to get through it. It's integrated the same way as it was in the last section, so I don't need to integrate it again. You end up getting an average value that's equal to 99.33 centimeters.